Concrete is the most widely used construction material in the world, and as such, it can be observed recurrently in several infrastructures, such as buildings, canals, tunnels, dams, or bridges. However, this material has also been used in the transport industry, and more specifically, in the construction of pavements. In the design of pavements, hydrological criteria play a fundamental role since a bad design can trigger dangerous scenarios for users, as well as preventing adequate mobilization and development of their daily activities. Taking this problem as a starting point, our proposal is based on the use of pervious concrete.
Pervious concrete refers to a special concrete in which there is a higher percentage of voids, which is achieved by reducing or not placing fine aggregates in the mix. Hence, it is sometimes referred to as a concrete without fines. Otherwise, pervious concrete continues to make use of Portland cement, water, coarse aggregate, and additives if needed. Besides, pervious concrete is composed of a relatively low water-to-cement ratio,
usually between 0.26 and 0.40,
which added to the percentage of existing voids, makes it possible for water to infiltrate through the structure of concrete at a rate of approximately 192 to 1724 inch per hour.
Thus, while a conventional pavement is looking for impermeability with runoff factors as near as possible to 1, the pervious concrete seeks precisely the contrary. That is, the water does not drain and rather infiltrate into the concrete, which brings several advantages. For example, fewer drainage works, which in turn implies a reduction in the total cost of the work. Reduction of hydroplaning, which can be very dangerous. Less glare from vehicle lights, which is very important, especially at night. Noise reduction when passing vehicles, which could become very annoying in busy areas.
Our central proposal consists of a competition designed for a future convention organized by the ACI, in which groups of students can venture into the design of a sample section of 40 by 40 centimeters, made entirely of pervious concrete. Given that pervious concrete is not designed to withstand high vehicular loads, it is encouraged to design a concrete capable of withstanding night loads associated with a parking lot, pedestrian walkways, sidewalks, or similar, which will be at the discretion of the participating group. Depending on the decision taken, the group should model its design and present different views or render type tours, if possible, simulating how it would act in the event of a flood. At that point, the joint work between engineering, architecture, and graphic design students is encouraged with a view to guaranteeing an optimal design from an aesthetic, structural, and functional point of view. The resulting mixture must have an infiltration rate greater than 3.5 mm per second, in a percentage of voids between 15 and 25%. The use of up to 2 additional cementitious materials such as fly ash or silica fume and up to 1 additive is allowed.
The elaborated sample will be placed on hollow support, on which the simple ring infiltrometer test will be carried out in accordance with ASTM C1701 to determine the infiltration rate of the concrete. Logically, the higher the infiltration, the higher the score. Since there is a series of spaces between the coarse aggregate used, it is necessary to guarantee adequate addition between them, for which the resistance to degradation will be measured in accordance with ASTM C1747. In this case, the lower the raveling, the higher the score. Render modeling will be evaluated by those attending the convention. In other words, in this contest, it will not only be the evaluation committee who decides the winner, but also the general public. Each team may earn up to 5 additional points if they have used recycled aggregates or have selected a particular case study on which to use their mix and develop a future maintenance plan. This is completely optional. In the event of a tie, the team that has chosen to carry out the optional activities will be the winner. If the tie is maintained, the winner will be the one with the sample with the lowest percentage of voids. As noted, the competition resembles remarkably a real project construction, where it is essential to forming multidisciplinary teams which work efficiently among the various areas. Additionally, it offers the opportunity to generate a bond between the participants and the attendees who, simulating the citizens, will take part in one of the qualification criteria, which will undoubtedly leave a precedent for future competitions.
On the other hand, it motivates undergraduate students to be closely related to pervious concrete, a variation of conventional concrete which makes it a sustainable material that requires less cement in its preparation and is capable of reducing stormwater runoff, supply the underground water reserves, allowing it to reach the surrounding vegetation and reduce the heat island effect generated by conventional concrete. These kinds of benefits are of the utmost importance since they help to reduce the large carbon footprint generated by concrete, which has led to various sources classifying it as the most destructive material on the planet. Our team is firmly convinced that concrete is a material with great benefits, evident in emblematic infrastructures worldwide. So far from demonizing it, we focus on looking for sustainable options to reduce its impact. We also refuse to visualize it as a gray and dark material that turns cities into concrete jungles, but rather an efficient and versatile material that can fit perfectly into the landscape. We are convinced that pervious concrete fulfills this objective and that after attracting the attention of future professionals, over time, constant flooding will be just part of the past, since pervious concrete will be their first and most appealing choice.